In our last video, we took a look at the cerebral cortex and the cerebellum. In this video, we're going to go over the hindbrain and the limbic system. So this time, let's start with the hindbrain and work our way up. The hindbrain sits at the back of your head, and it's responsible for essential life-sustaining functions. It includes the medulla, the pons, and the cerebellum. And we've already covered the cerebellum, so let's take a look at the medulla and the pons. The medulla sits at the base of your brainstem, and it controls autonomic functions that are critical for survival. These functions include regulating your heart rate, your blood pressure, and your breathing. And if you damage your medulla, that's going to be life-threatening. Also, if you're a fan of mixed martial arts, you'll know that one of the only rules is that you can't strike the back of the head. And this is the reason for that. Okay, next up we have the pons. The pons sits above the medulla, and it contributes to breathing regulation, and it also manages our sleep patterns. You might have heard about the cycles that we go through when we're asleep. Well, the pons helps us fall into what's called REM sleep, and the REM stands for rapid eye movement. And this is the phase of sleep in which we have dreams. Okay, next up we have the reticular formation. The reticular formation is a complex network of nuclei that goes through the brainstem, and it connects to the thalamus. This structure is involved in the process of bringing you out of sleep and then regulating your alertness and focus once you're awake. So if you have damage to this part of the brain, you may fall into a coma and be unable to wake up. It also manages our ability to selectively pay attention to stimulus in our environment. So imagine you're in a crowded cafeteria. Then someone a few tables away says your name. Even if you're not listening to that conversation, you'll still hear your name. This is called the cocktail party effect, and we can thank the reticular formation for this ability. Okay, moving on. The limbic system is a network of structures that regulates emotion, motivation, and memory. It includes the thalamus, the hypothalamus, the amygdala, and the hippocampus. And let's start with the thalamus. The thalamus is often referred to as the brain's relay station because it receives sensory information, except for smell, and directs it to the appropriate areas of the cerebral cortex. This is a critical process that enables us to perceive our environment. And next up in the limbic system is the hypothalamus. The hypothalamus sits just below the thalamus, and it manages a variety of bodily functions. It regulates body temperature, hunger, thirst, and our drive to reproduce. And if you damage this part of the brain, it could result in an inability to feel hunger, or perhaps an even worse fate. You may never feel full. Okay, now let's look at the amygdala. The amygdala is famous for its involvement in emotion processing. In particular, it deals with fear and aggression. In one very famous case study, there was a patient known as SM. SM had a disease that caused damage to her amygdala. The result? She was unable to feel fear. And this effect was so extreme that after being attacked by a man with a knife, she didn't even call the police. And then later, she kept going back to the same park where that attack happened. So it turns out that being afraid of things can be pretty helpful sometimes. Okay, the last structure in the limbic system is the hippocampus. The hippocampus is instrumental in creating new memories, particularly what we call episodic memories. One famous study that illustrated the importance of the hippocampus was the case of the man named HM. Also, who's naming these people? Anyways, after an accident in 1953, HM began having really bad seizures. So, in an attempt to cure him, surgeons removed his hippocampus. And thankfully, the seizures did stop. But HM lost the ability to form new memories. Not exactly a perfect outcome, but before this, they didn't know that damage to the hippocampus would do that. Okay, the final structure that I want to talk about is the corpus callosum. The corpus callosum is a bundle of nerve fibers connecting the brain's two hemispheres. This neural bridge helps our left hemisphere and right hemisphere communicate. And some very interesting research has been done by a guy named Michael Gazzaniga that helps us understand it. Gazzaniga works with people who have had their corpus callosum cut, which effectively makes it impossible for the two sides of your brain to communicate. This so-called split brain research has shown that the left hemisphere is specialized for language use, and the right hemisphere is specialized for spatial tasks and creativity. But contrary to popular belief, you do not have a dominant hemisphere. That's an old idea from the 1960s, and a lot of brain scans since then have debunked the idea. Okay, that's it for the brain. In our next video, we'll take a look at the different methods that we use to study the brain.